So the modeling approach that was applied, our consultants applied something called the CMAQ model, the Community Multi-Scale Air Quality Model. And this is a model that's been applied successfully previously in the Pacific Northwest by Environment Canada. And the strength in the model is basically in the comparison of different policy options. So in that sense, it's ideally suited to compare the different alternative scenarios that were developed by the AECOM group. The model considers meteorology, atmospheric chemistry, and emissions. And knowing that it's been previously applied in the Pacific Northwest, it was already set up with a representative meteorological data set, atmospheric chemistry, and in fact was pre-populated with all of the emissions for our airshed. The model runs, the consultants were directed to develop worst-case conditions, in other words, the maximum possible air quality levels that could result from the waste management scenarios. In other words, what they modeled was basically the perfect storm for a summer ozone condition. They did this for the 2005 base case. This provides a basis of comparison of the future scenarios to the present day. And then they modeled all 8 of the 2020 scenarios, and this allows a comparison of the impacts across the scenarios. And the model has the ability to resolve ambient air quality emissions at a resolution of 4 kilometers. Visually, what this means is if you superimpose a graph of 4-kilometer grid squares over top of the airshed, the model would be able to predict the ambient air quality in any one of those 4-kilometer squares. So these are the results of the model. This is regional ozone levels for 2020 compared to 2005. The approach we use here is to index everything against 2005 levels. So the blue bar on the left is 100%. That's 2005 ambient air quality. And all the bars to the right of that are the comparison against that. So where we see 86%, that basically means a 14% improvement relative to 2020. The thing to note about ozone is that it's not released directly from any sources in the region. It's formed secondarily as a result of reactions between nitrogen oxides and VOCs in the presence of sunlight. This is one of the reasons ozone is prevalent in the summertime. So the key observations here is that, as we showed earlier, the ozone precursor emissions are going down, so the modeling does predict improvements to the year 2020. And the other key observation is that there is no discernible difference between the scenarios, and this is somewhat intuitive, knowing that the contributions of NOx and VOC to the airshed loadings are as low as 1% and 0.1% respectively. Just for illustrative purposes, we also are showing the model results for one of those 4-kilometer grid squares. This is the one for Chilliwack. We see a very similar finding as we saw for the entire airshed, although the improvement from 2005 to 2020 is not as pronounced as it is in the overall airshed. Nevertheless, there is an improvement, and again, it's related to the ozone precursors going down. And the same result in terms of comparing the scenarios, no discernible difference between the scenarios. The model was also set up to establish regional PM 2.5 levels. This is secondary particulate concentrations. Particulate is a little bit different from ozone. There is some that is released directly from emission sources, but there's also some that is formed secondarily. And it's formed as a result of reactions between NOx and SOx and ammonia in the airshed. So the same approach here. The blue bar on the left is the 2005 level, and the 3 scenarios are compared against that. So we know that the PM precursors, NOx is decreasing while SOx and ammonia are increasing. So the modeling predicts about the same levels to 2020 in terms of ambient air quality with some small improvement. It's important to note that the changes are not due to the waste management emissions. And similar to the ozone result, there's no discernible difference between the scenarios. So to summarize the observations, airshed-wide improvements in ambient levels of ozone and PM 2.5 are predicted. This is due to declining emission levels of several of the precursor emissions. This would lead to regional health benefits. Future waste management emissions under any scenario are comparable to present day and are very low relative to airshed totals, ranging from, as we showed earlier, less than 0.1% to about 1.2%. And the modeling shows no discernible difference between the scenarios. So the conclusion here is that ambient air quality is not a determining factor in choosing between waste management options.